Hello friends, now we will see our first program for timer experiment, blinking of LED. Blinking of LEDs connected to port D. With 1 second delay using timer 0 without interrupt. So for this, first of all, we need to perform few calculations. So here, assume the crystal oscillator frequency is equal to 20 megahertz. Assuming 20 megahertz of crystal frequency, we need to first of all find out the initial value to be loaded in the timer. So for that, we have to first find out the desired count need to be counted for generation of 1 second of delay. So for that purpose, we have to start with to find out the timer frequency first. So frequency for the timer will be the default frequency, which is f oscillator divided by 4. So if we calculate 20 megahertz divided by 4 will be the timer frequency. Now if we assume the prescaler required for timer 0 is equal to 256, then the frequency for timer becomes 20 megahertz divided by 4 into 256, because the entire frequency will then be divided by the 256. As the 256, we have taken 256 as a time as a prescaler. Okay, so if we calculate this, so this is your timer frequency. The reciprocal of this timer frequency is going to a period of one single cycle for the timer to count the pulses. So period of one single cycle would be it is going to be the reciprocal of 20 megahertz divided by 4 into 256. So this will give us the answer is equal to 51.2 microseconds. Okay, so now as we got this value, now this is the duration of one single cycle. So such how many cycles the timer 0 need to count for generation of 1 second delay. So for that will give us the desired count. So the desired count will be 1 second divided by 51.2 microseconds. So it will give you the count which is equal to 19,625. Now this is the desired count. Now as the timer in PIC microcontroller is a up counter. Okay, so for that we need to find out the initial value to be loaded into the timer. So the initial value to be loaded will be the maximum value of timer minus the desired count. So it will be 65,536 will be the maximum count, as we are operating timer 0 in 16-bit mode. So the maximum value will be 65,536 minus the desired count is 19,625. So this will give us 45,911. Now this is in decimals. Okay, to load this value into the timer register, we need to convert it into the hexadecimal form. So the converted hexadecimal value is B3 B4H. So here your TMR0H will be loaded with the B3H and TMR0L register will be loaded with B4H values. So these are going to be your initial values that has to be loaded in the timer register. Now we need to find out, we need to configure timer 0, and to configure timer 0 register we need to configure T0 con register. So T0 con register is basically the timer 0 control register. Okay, so it is basically the 8-bit register. So these are its bits. So this is bit number 0, bit number 1, bit number 2, bit number 3, bit number 4, 5, 6 and 7. Okay, so bit number 0 is basically TMR0 on. Bit number 6 is T0 8-bit. So TMR0 is to start or stop the timer. T0 8-bit is to decide whether to operate it in the 8-bit mode or 16-bit mode. Next is T0 CS is to decide the clock source. Next is the T0 SC, it is for the synchronization purpose. And then T0 PSA, it is to whether to assign the prescaler or not. So if it is 0, the prescaler is assigned. If it is 1, the prescaler is not assigned. And next it is T0 PS2, T0 PS1 and T0 PS0. So these are the prescaler bits. Now as we have taken the prescaler value which is equal to 256 here, okay, so we have to take the corresponding value of prescaler will be 111. As a prescaler is assigned, so this value will be T0 PSA will be 0. Right now the synchronization is not required as we are not using external clock source. Then T0 CS is the, as we are will be also equal to 0 as we are using the internal clock source. We are operating timer in a 16-bit mode, so this bit will also be equal to 0 and we have to make timer on. So this bit we will make it equal to 1. So the corresponding value becomes 87. So this is 8, this is 7H. So the T0 con register will be loaded with 87H value. Now we will see the program for the timer 0. So we will begin with hash statements. So hash include, we need to first include the header file. So hash include P18F4520H as the header file, which will include all the headers in your software, in your program. Okay. Next we will make use of pragma statements. So hash pragma config oscillator is equal to HS. Remember friends, hash pragma config, this statement is basically used to configure your hardware. These statements are directly going to configure your, will make the changes in your hardware. So we can directly configure the hardware by making, by writing these statements. So first of all we need to make some changes in the configuration bits. Those configuration bits will in turn configure your hardware on the board. Okay, so next hash pragma config PWRT, which is power up timer, so we will make it off. Next hash pragma config WDT, which is watchdog timer, we will make it off. hash pragma config LVP, which is low voltage power, we will make it off. Next, hash pragma config PBADEN, we will make it off. PBADEN is a bit which will initially, the port B bits that are basically assigned internally to the ADC are by default configured as analog inputs, but here if we want to make the port B bits as an input output port, then you have to make this bit is equal to off through the configuration bits. So after making the changes in the configuration, we'll first declare our user defined function that is void. Let us give name as timer 0 delay void. So this is function declaration, and now we will begin with the main. So void main. So inside main, we will first give a call to the function. We will first define the direction of a port D. So by configuring tris D register with the value of 0x00, we are basically configuring, we are basically making port D as output port. Okay, so with this we are basically configuring the port D as output, as LEDs are connected to the port D. Okay, after that, as we have to blink the LEDs continuously, we have to make use of while one, which is a continuous loop or endless loop. So inside while one, we will first make port D is equal to 0xFF, and then we will give a call to our user defined function, that is timer 0 delay. Again we will make we will off the LEDs by writing value as 0x00 to the port, and we will give a call to function as timer 0 delay. Okay, we will close this while one, we will close this main. Now we have to write the function definition for timer 0 delay. Now in this function definition, first we will configure the timer by putting the value into the, by putting the 87H value into the T0 con register. Okay, so now we will write a function for timer 0, a user defined function. So we will begin with void timer 0 delay function definition. So inside this function definition, first we will configure T0 con with the value of 0x87. Then we will load the timer with its initial value, which we have just now calculated, that is TMR0H will be loaded with the value of B3. Okay, and TMR0L is loaded with 0x B4. After that, we have to make the TMR0 IF bit off. Okay, so for that purpose, the TMR0 IF is a overflow flag for timer 0, and that bit resides in a INT con register. So we will configure that bit with the INT con bits dot TMR0 IF is equal to 0. So we have to make first that bit 0, and then we have to wait for that bit becomes 1. So TMR INT con bits dot TMR0 IF is equal to 0. Okay, and we have to put a semicolon after this while. Why this while is important? Because the program counter or the program will stuck at this while statement till this TMR0 IF bit is 0, and still your timer is not overflowed, the TMR0 IF remains 0. So as soon as the TMR0 IF bit becomes 1, this while condition will be false. It will come out of this while, and that indicates that timer has overflowed, which in turn shows that timer has generated a desired amount of delay. Okay, so once this condition is false, it indicates that timer is overflow. So if the timer is overflow, our first task is to turn off the timer. So T0 con bits dot TMR0 on is equal to 0. Okay, and then we have to clear this bit once again, TMR0 IF. So again, int con bits dot TMR0 IF is equal to 0. So this ends the timer 0 delay function. So this is the program for the timer LED blinking with timer 0, and the delay that we have generated is for 1 second. Thank you. Thanks for watching.